Good evening everybody, let us start with the class. Good evening everybody. So, today we would see the index properties of soil. So, let us start our discussion with the index properties of soil. Now, I would be using the consistency limits that we have covered in the last class. Hopefully, you have revised it. We will be using those consistency limits to see the various index properties of the soil. So, let us start our discussion. Let us start, my dear friends. Are you there? Please comment. Let us start the discussion. Let us start your discussion. Let us start your discussion. Are you all there? Have you revised the last class? In the last class, we have discussed about the Atterberg limits. Today, I would be using those Atterberg limits to define various index properties of soil. So, let us start with the most basic index property, that is the plasticity index, represented by a symbol IP. Now, see what is plasticity index of soil. Let us see the plasticity index of soil. Okay. Let us talk about the plasticity index of soil. So, how this IP of the soil is defined? What is IP? Let us see. So, how is IP of the soil is defined? Let us see. Represented by a symbol IP, plasticity index, IP. How is IP defined? Let us see. See, we already know this curve, this Atterberg graph we have already seen. Volume versus water content, you remember now? Now, IP is the range of moisture content over which my soil is showing plastic behavior. This is WS, WP and WL, and this is VD. So, this is the range over which my soil is showing plastic behavior. So, this is the range over which my soil is showing plastic behavior. So, IP is nothing but this range, that is IP is equal to WL minus WP. So, it is nothing but the range of moisture content over which my soil is showing plastic behavior. So, the range of moisture content over which the soil remains plastic is called plasticity index, that is IP, and here WL and WP should be in percentage. WL and WP is in percentage. It should be in percentage. So, WL and WP should be in percentage here. See, more is the value of IP, it means more plastic is the soil, means it can absorb large quantity of water without getting converted into liquid state. And this plasticity behavior is generally shown by clays. Why? Because the surface of the clay is negatively charged and water is a dipole, and plus due to the very small size of the clay, the specific surface area is very large. So, clay can assimilate or absorb large quantity of water without getting converted into liquid state. So, this plastic behavior is generally shown by clays. Got my point? So, the property is exhibited by clay due to presence of clay minerals which has smaller grain size, thereby large specific surface area, that is surface area per unit mass or volume, and charged surface. Due to these properties, clay can assimilate large quantity of water without getting converted into liquid state. Normally, the value of IP of clay is between 15 to 100. If IP is 0, means the soil is non-plastic, like gravels and sands. So, gravels and sands are non-plastic soils. Okay. Now, we have the range of value of IP. If IP is 0, soil is non-plastic. You have to remember this range directly. Many times questions are asked from this table as well. If IP is 0 to 7, it is low plastic. If IP is 7 to 17, then it is medium plastic, and lastly IP greater than 17 means the soil is highly plastic in nature. Got my point? Clear? Very good. No problem till here. So, this was all about the plasticity index. Now, let us see the next index. Like this, I will define variety of index today. Next is what? Next is my consistency index. Next index is what? Consistency index, represented by a symbol IC. Okay. This consistency index is represented by a symbol IC, and it measures the degree of firmness of soil at its natural moisture content. How it is calculated, let us see now. How this is calculated, let us see. Very interesting. Please focus on the board. Represented by a symbol IC. So, IC represents the degree of firmness of soil at its natural moisture content. If IC is more, the stiffness is more. And how IC is calculated? IC is equal to WL minus W upon WL minus WP. This is my consistency index, where W is a liquid limit, W is the natural moisture content of the soil in its natural condition, and WP is the plastic limit of the soil. So, one thing you can see that if W is increasing, then my IP will decrease. Sorry, if W is increasing, then IC will increase. Sorry, IC will decrease. Or if W is decreasing for a given soil, WL and WP is constant. So, IC will increase. So, lesser is the moisture content, the soil will move towards the solid state, that is its stiffness will increase. Therefore, I am saying that more is the value of IC, more would be the degree of firmness or stiffness of the soil. So, consistency is used to study the in situ behavior of saturated fine grained soil at its natural moisture content. Now, we have one more index that is similar to consistency index, and that is known as a liquidity index. How liquidity index is calculated? IL. IL is equal to what? That is W, it is W minus WL, sorry, W minus WP upon WL minus WP. This is my IL, and it is the reverse of IC. If IL increases, it means what? The liquidity nature or the softness of the soil is increasing. And one more thing you can see, that IL is equal to 1 minus IC. I can prove it as well. IL is equal to 1 minus IC. So, if 1 minus IC is what? 1 minus WL minus W upon WL minus WP. So, WL cancel. So, it will come out to be W minus WP upon WL minus WP, that is IL. Okay. One thing also you should understand, that at W is equal to WL, IC is what? 0, and at W is equal to WP, IC is equal to 1. Means all soils at plastic limit will have same value of IC, means with the help of this IC you can't compare the stiffness of soil at plastic limit. And for IL it will be reverse. At W is equal to WL, IL is equal to 1, and at W is equal to WP, IL is equal to 0. And various range of IL and IC is given in this table, just decrease by 0.25. IC can be greater than 1. If W is less than WL, sorry, if W is less than WP, in that case my IC can be greater than 1. You are moving towards a semi-solid and a solid condition, means the soil is very brittle. Decrease by 0.25 now, just decrease by 0.25, 0.75 to 1, 0.5 to 0.75, 0.25 to 0.5, 0 to 0.5, and lastly negative. It can be negative if W is greater than WL, means the soil is liquid. So, brittle, stiff, medium, soft, very soft, and liquid state. See, with medium we never write medium stiff or medium soft, because both is same only. Either you call it medium stiff or either you call it medium soft. It's like seeing a half glass, glass filled with half water. So, you can say that glass is half full or half empty, it is one and the same thing. Similarly, medium soft and medium stiff is same. So, we are writing only medium here. And for IL, what I can say for IL? This would be IL, IL I know 1 minus IC. So, when IC is greater than 1, IL is less than 0. Increase by 0.25, that is it. More is the value of IL, more would be the softness or liquid behavior of the soil. So, this chart also you will remember. Got my point? Very simple. So, this was all about consistency index and liquidity index. Any doubts still here? Can I proceed? Please tell Mr. Akash. Any doubts still here? Then I will show you the toughness index in detail. Then I will see the toughness index in detail. Okay. Now let's talk about the toughness index. What do you say? Let's talk about the toughness index. Am I clear till here? Then I will proceed towards the next index properties. Any problem? Okay, Mr. Akash, then proceeding towards the toughness index. Represented by symbol ITC, we have a problem here. What is the problem? That at liquid limit, I saw that IC is same. So, we cannot compare the firmness of soil at liquid limit, at plastic limit, IC is 1. At liquid limit, all soils have same shear strength. But at plastic limit, your different soils will have different strength or different stiffness. But with the help of IC, you won't be able to compare, because for all the soils at WP, your IC is 1. So, now to compare the stiffness of the soil at plastic limit, that is toughness of the soil at plastic limit, we have defined IT, that is the toughness index. See, if the soil is more tough at plastic limit, it means what? You will have to apply greater pressure to roll it into a thread of dia 3 mm. So, if that is my, so toughness index, let us talk about this toughness index IT here. IT is what, my dear friend? What is IT? IT, how you will define? IT is nothing but the ratio of IP upon IF. IP is what? The plasticity index, that is WL minus WP we have seen. And IF, you remember in the last class we have seen, that is the flow index, negative of the slope of the flow curve. From the Casagrande's experiment we have seen this, that IF. Now IT, what it indicates? It indicates the toughness or shear strength of the soil at plastic limit. So, if you have to compare the stiffness of the soil at plastic limit, we will go with the toughness index. How I can prove this? Very simple. You remember, this is IF, this is my IF here, okay. That is the negative of the slope of this flow curve. You remember, Wn log n is the number of blows. So, IF is nothing but WL minus WP upon log N1 upon N2, or NL upon NP, I can say. NL is the NP upon NL, that is number of blows at plastic limit upon number of blows at liquid limit. I can say like this, this is my IF, N is number of blows. Now, if I write down the equation of this straight line, what I can say? See, if I write down the equation of this straight line, what I can say here? See, if I want to write down the equation of this straight line, let me deduce it further for you. See, if I want to write down the equation of this straight line, that is y is equal to mx plus c, that is c minus if, slope is minus if, into log n. Now, WL is equal to c minus if log NL. NL is the number of blows at liquid limit, and WP is c minus if log NP. NP is the number of blows at plastic limit. Just subtract these two. So, what you will get, WL minus WP is equal to IF log NP minus log NL, log A minus log B is log A by B. So, IF is equal to what? Or IP is equal to IF or IP upon IF is equal to log NP upon NL. This is nothing but my IT. Now, for all soils, the soils, NL is same, है ना? Okay. Now, for all the soils, my NL is same, NL is constant, N is the number of blows, NP is the number of blows at plastic limit and NL is the number of blows at liquid limit. Now, one thing you should understand, here IT I got as IP upon IF log of NP NL, this is NP, this is NL, this I got, I have proved it also. NP is the number of blows at plastic limit and NL is the number of blows at liquid limit. And N is direct, number of blows will be directly proportional to shear strength. For all the soils, my NL is constant, that is 25. Only NP will change. So, if IT is more, I can say that NP is more, that is shear strength of soil at plastic limit will be more, because you will require more number of blows at plastic limit. So, therefore, all soils have same shear strength at liquid limit, because NL is constant. But if more is the value of IT, I can say that the soil will have more toughness, that is, it will exhibit more toughness at plastic limit. Okay. So, I can say this thing. Got my point? So, IT indicates the strength of soil at plastic limit. More is the value of IT, it means more would be the toughness of soil at plastic limit. Clear? I am covering almost all theories in detail for this chapter, Mr. Akash. All the theories I am covering in detail only. Did you get the definition of IT here? Now, let us talk about the relative density. So, IT, the value of IT is generally between 0 to 3, okay. The IT is generally between 0 to 3. If IT is between 0 to 1, it indicates friable soils, that is easily crushable. It indicates friable soils. Friable means easily crushable, like silts. Silts are easily crushable. Silts are easily crushable, but clays you won't be able to crush the clays easily. And if IT is 1 to 3 for clays. For clays generally my IT will be between 1 to 3. It indicates clays. Got my point? IT will have a range between 0 to 3. No problem. Now, let us talk about the relative density. Mr. Akash, whatever I am covering, it is all in detail only, but not the total geotech we will cover here obviously. In so limited time, it is not possible to cover the complete geotech. Geotech in itself is a very huge topic. It can be covered with 100 to, we require around 100 to 120 hours to cover the complete geotech. But yeah, this lecture will help you to make a base, and with the help of these lectures you will have more interest in studying this geotech. Okay. Anyways, let us proceed further. So, am I clear till here? This was all about IT. Am I clear till here? Then I will proceed towards the next index, that is the relative density or the density index. Is it clear? Can I proceed further? Tell me fast, my dear friends. Clear till here? Now let us proceed towards the next index, that is relative density or the density index. How it is defined? Relative density is E max minus E natural upon E max minus E minimum. E max is the maximum void ratio in the loosest condition. E natural is the void ratio in the natural condition, and E minimum is the void ratio in the densest state for the soil. So, this relative density is for coarse grained soil. This index is defined for a coarse grained soil, not for a fine grained soil like sands. This is defined for a coarse grained soil like sands and gravels. It indicates the denseness of the soil. So, for a given soil, E max and E min is same. E max and E min is constant for a given soil. So, E natural can change. So, if E natural is decreasing, Dr is increasing, means the soil is more dense. So, it indicates the denseness or looseness of soil at its natural void ratio, and it is equivalent to IC of clay. See, IC is not defined for sands and gravels. So, for sands and gravel, to check the denseness or looseness, we will have the relative density. So, degree of denseness or looseness of natural deposit of coarse grained soil is studied in terms of relative density. Dr of coarse grained soil is equivalent to consistency index of fine grained soil. See, generally this value of E max is less than 0.91 and E min will always be greater than 0.31. But for a given soil, E max and E min will be constant, and for different sands and gravels, E max and E min will be different. If you change the soil, E max and E minimum will change. Higher relative density indicates denser soil having larger shear strength as well as lower compressibility. Got my point? So, if Dr is less than 15%, it indicates very loose soil. If Dr is between 15 to 35%, it indicates loose soil. 35 to 65% will indicate medium soil, 65 to 85% will indicate dense, and greater than 85% will indicate very dense soil. Please remember this chart as well. So, this was all about the relative density of soil, okay, or the density index. Okay. Now, let us talk about the sensitivity. Next index property will be sensitivity. Is it clear till here? So, this relative density is defined for a coarse grained soil. Please note till here. If you have any doubt, please ask me. Clear? Am I clear till here? Let us proceed. Now next is sensitivity of the soil. It indicates what? Degree of disturbance created. See, whenever we remold a clayey soil, its shear strength decreases due to breakage of soil structure. So, sensitivity measures the degree of this disturbance only. So, how is this sensitivity defined? Sensitivity is defined like this. See, sensitivity is equal to what? Represented by symbol ST. Sensitivity is equal to QU undisturbed upon QU remolded. Okay. This is how sensitivity is defined. So, QU is nothing but the unconfined compressive strength of the soil. It is thus indicative of the degree of disturbance created or the loss of shear strength on remolding. More is the value of sensitivity, it means more would be the disturbance or the loss of shear strength on remolding of the soil. Whenever we remold the clays, its structure gets broken down and its shear strength decreases or its unconfined compressive strength will decrease. Okay. Now, if ST is equal to 1, it is indicative of coarse sand or gravels. They will not show this property. This is shown by clays. If sensitivity is between 1 and 4, it is normal sensitive. If sensitivity between 4 and 8, it is sensitive. And if sensitivity is between 8 and 15, then soil is extra sensitive. And if sensitivity is greater than 15, it is unstable or quick clay. See, sensitivity can be less than 1 as well. It is for fissured or cracked clay. See, cracked clays are already weak. But when we remold these soils, its weakness will disappear, the cracks will disappear and these soils will show more shear strength in that case. Okay. So, this was all about the sensitivity. Got my point? Clear, my dear friend? Is it clear till here? Is it clear sensitivity? Now, last index property then I will cover, that is activity of the soil. It indicates the swelling or shrinkage characteristics of clays. If soil is active means it will swell more and shrink more, and activity is seen with the help of IP and percentage of clay particles. So, activity number is defined like this, that is IP upon percentage of clay particles. If AC is more, soil will be more active, it will show more swelling and shrinkage behavior. So, activity number is used to study the swelling and shrinkage characteristics of soil. Swelling and shrinkage characteristics of soil was found to be a function of IP and percentage of clay particles. If AC is less than 0.75, it is inactive soil. If AC is between 1.75 to 1.25, it is normally active, and if AC is greater than 1.25, means it is very active soil like montmorillonite clay or bentonite clay or the black cotton soils. These are more active soils. Very good, Mr. Akash, you are very correct. Now, let us do some numericals on these concepts today. So, this was all about the index properties that you should remember, my dear friend. Now, let us do some numericals on these concepts. Okay. Let us see. Let us do this one. Very good numerical. Please try to solve this one. Okay. Very interesting numerical. Please try to solve this. Do it fast. Please solve it. Very interesting question. Let's see, C is the answer you are getting, C is correct answer beta. So let's try to solve this for you, let us try to solve. A saturated clay layer have a natural moisture content of this one. The natural moisture content was given, lab test showed me the liquid limit as well as the plastic limit. Liquid limit is how much? That is 52%. Plastic limit is how much? That is 24%. Very great. Now, new moisture content is W new 6%. Now, find while the consistency due to C, while the consistency limits unchanged, what will the absolute difference between the new consistency? So, consistency limits are not changing. So, we have to find out the difference between IC new and IL new. So, earlier natural moisture content was given just to confuse you. IS new is equal to what? WL minus W new upon WL minus WP. 52 minus 6 upon 52 minus 24 is equal to how much? Tell me. And IL new is equal to how much? W new minus WP upon WL minus WP. That is 6 minus 24 upon 52 minus 24 again. How much you are getting? Tell me fast. This is new moisture content is how much? Sorry, it increases by 6%. Very sorry, this is, I have written it wrongly, please forgive me. This is 36 plus 6, that is 42%. This will be 42, 42. Now it's perfect. So it is 10 by 28 and then 18 by 28. Very good. Now difference between IL minus IC new, 18 by 28 minus 10 by 28 is 0.29. So correct answer is C, my dear friend. That is very correct. Very good. Very good, Mr. Akash. Very simple question, but interesting one. Let's see the next one. Let's see the next question. Let's see. Try to solve this one, please. Try to solve this one. Okay, try to solve it, please. Make it fast. Very good. So, activity number you have to calculate here. Very interesting question on activity number. Activity number is what? IP upon percentage of clay particles. IP is what? WL minus WP. It is WL minus WP upon 100 minus percentage of silt. See, we have a clayey silt here, a fine grained soil, while with the remaining fraction being a 65% silt size particle. So, 54 minus 22, 54 minus 22 upon 100 minus 65. So, AC please calculate and tell me. It is 0.91 and AC is between AC is less than 1.25 and greater than 0.75. It means it is normally active. This soil is what? Normally active. So, correct answer is what, my dear friend? Tell me fast. 0.91 and normal active means B is the correct answer. B you are giving. Very good, very good, very good, Mr. Akash. Very good. So, these kind of questions you can very much expect here. Okay. Okay. So, this was all about the index properties of soil. So, tomorrow we will have the last lecture on unit weight determination. Tomorrow we will meet and I will show you how to determine the unit weight of soil. So, this is my Telegram channel. You can always subscribe me here if you have any queries. Bye bye everybody. Take care. Thanks a lot.